Good afternoon. It's always nice to be the last speaker at a conference. I'll let you figure out why for yourself, but I want to take this opportunity for thanking Susan and her team for organizing this excellent NANOG meeting here in Washington, D.C. And I think I speak of everybody when I say thank you, Susan. In the last 30 minutes of this conference, I would like to bring you up to date on what we are doing in the Netherlands, in Europe. And before I enter the real presentation, let me explain to you where the Netherlands is. This is a map of Europe. The red circle is the Netherlands, and this country is 4 by 6 milliseconds in round trip time wide. The neighboring counties are Germany, Belgium, and there's the North Sea to the left side of the country. Right. I want to share with you a few things on what we are doing inside the Gigaport project. The company I work for is called SURFnet, and we are the equivalent of the Internet 2 organization in the US, sort of. In 1-2 slides, I want to bring you up to date on SURFnet and the Gigaport project, and then I go to what we're doing in building the next generation network for us, SURFnet5. And I want to show you how this network is connected to the rest of the world through what we call the external connectivity. And I'll end with some closing remarks. Right, first of all, SURFnet. We are the network that provides the Dutch research and education community with networking facilities, not only building the IP infrastructure, but giving them the wholesale connectivity, the wholesale package. This is different from what the US and Canadian universities are experiencing from their Abilene or Canary connection. We provide them with global internet connectivity as well. SURFnet is a not-for-profit company, not for loss either, by the way. It means that if we make some profit, we put it back into the infrastructure. We have 200 connected organizations. Behind those 200 connected organizations, there are also 50 more organizations that use our infrastructure. And within the 250 organizations connected to our network, we estimate the user base 400,000. The turnover last year of the company was 20 million euros, which used to be roughly $20 million. It's slightly less now. The infrastructure services we provide are paid by the customers themselves as long as it is operational. All innovation is paid by Dutch government. Let me give you an overview of the speeds that we use and are using and will be using to connect customers with. We started back in the mid-80s with an X25 network, 9.6K, and at that moment in time everybody was thinking about OSI protocols. Back in '89, as one of the first countries in Europe, we started with the IP protocol, and we built our private X25 network on which we did IP. If you look further to the right, the technology we used and are using became simpler. Today we are somewhere in the middle between the two right poles. We do operate the network called SURFnet4, which is an IP over SDH, IP over SONET network with OC12 speed, and it's IP over SONET over glass. And our next generation network will be simpler. It will be IP over glass or IP over lambda. We're building this together with Telfort, a wholly owned subsidiary of British Telecom, and Cisco Systems. And the pilot network is up and running, and I'll come back to that later. Right, first, the Gigaport project. The largest harbor in the world is Rotterdam, the second city of the Netherlands. And one of the main ports to Europe through the air is Schiphol Airport in Amsterdam. And thinking on how to go further with the infrastructure for the Netherlands, we thought, well, we need a third main project for making sure that the Netherlands, 4 by 6 milliseconds wide, is on the map. We acknowledge that we could not pay for the new infrastructure just by ourselves, so we started an initiative, the Gigaport initiative, We started it back in early '97 to make the politicians aware of what we were doing and why it is needed to increase the infrastructure needs, or sorry, increase the infrastructure funds for also building not only bridges, railways, etc., but also building networking. There's a lot of natural gas in the Netherlands, and what Dutch government does is that they do not spend it just like some of their income. It's put into a pot, and it's called the infrastructure account. And recently, I think it was back in '98, sorry, there was a decision by the Prime Minister that these funds can also be used for knowledge infrastructure. And that gave us the green light for having a grant of 162 million Dutch guilders, which roughly equals to 71 million euros, for building the Gigaport network in the period 1999 to 2002. And there was SURFnet is a company that was established in the mid-'80s, and we are doing IP networking since then. There is a similar institution in the Netherlands called the Telematics Institute, and they look into internet applications. And the Gigaport money was not used to set up a brand new organization. It leverages on the existing organizations, for SURFnet doing the network part, and for the Telematics Institute doing all the application stuff. We are participating in the Telematics Institute, and one of the projects we are engaged in is video over IP. And I planned on, I have to say this, I planned on giving a small demo of live Dutch television here at the NANOG, but there seems to be a multicast problem, and unfortunately, next time I hope. Right, back to my presentation. The main challenges for the Gigaport project are the last mile, at least, I mean the cost of the last mile. We heard a nice presentation by the FCC folks yesterday that it gave me the impression that in the US the last mile is not such a big problem. But let me assure you that in Europe the last mile is a big problem. When you look at my country, where Amsterdam and Rotterdam are, that is to the western part of the Netherlands, the last mile problem is there, but it's becoming less. If you go to the rest of the Netherlands, the rural part, forget about having any connectivity beyond ISDN. The Netherlands has 14 universities and they're scattered all over the country. So we do have last mile problems for reaching all the universities. Through the Gigaport project, we achieved to share the need for this network, for the project. And from the highest politicians to the researchers inside the university, they're now aware of that there is an urgency but also an opportunity for building the next generation. As I said in my introduction, we not only provide the Internet 2 type connectivity towards the Dutch universities and higher education and research institutions, we also do full Internet service provision for them. This is exactly the target group for SURFnet, and this is exactly the users we have been servicing for, since the beginning of the company. However, within the Gigaport project, industry can connect to our network as well and use our network as well for doing application research. And we now see a number of organizations, commercial institutions, commercial organizations connecting to our network. Recent examples are IBM. They have the iCare Center in Chicago. They opened a similar center in the Netherlands, which does the iCare activity for Europe, the Middle East, and Africa. They're connected to the Gigaport network. Another example is Ericsson. They connected on 2 locations. Right, let me give you the goals for the Gigaport network part for the end of the project. The project itself falls into 3 sub-projects. The first one is the National Research Network, building the next generation network for us. And the description we have for SURFnet5 is it should be 100 times faster than the existing network. The number of POPs will not increase. Today it's roughly 15 and will remain 15, although there are activities for having additional funding for 10 more POPs. And the access to the POPs, towards the POPs, should be 20 gigabits per second, end of the project. As I said, we're looking for IP over optical transmission, and our network instances are never frozen in the sense that we do not improve the networks. Recent additions are that we do have native multicast enabled on our entire network. IPv6 is now in pre-production phase. We have an overlay network for that, but the plans are to have it native on the backbone real soon now. Other parts of the Gigaport network project are, doing the access project. Today we're engaged in a project that, with the Technical University of Eindhoven, a university to the southern part of the Netherlands, for having a GPRS pilot. And for those of you that are not familiar with mobile terminology in Europe, GPRS is the successor to GSM. GPRS makes it possible to have always-on IP connectivity at data rates up to theoretically 200 or 300 kilobits per second. And the next step after GPRS will be UMTS, and we will be looking at to that as well. But also we are engaged in different ADSL projects, and we are planning on cable modem projects as well in the future. Our external connectivity is part of the Gigaport network project as well, and that has mainly to do with funding. Roughly half of the money goes to the funding of the international connectivity. And lots of gigabits here on the slide. The end target for 2002 is that we connect to the Amsterdam Internet Exchange at 5 gigabits per second. We probably will do better. We plan now to have 10 gig ether there. Amsterdam Internet Exchange, one of the two largest exchanges in Europe, together with London. Today we are connected to the Amsterdam Internet Exchange at 1 gig. Later this year it will be 2 gig, so we should be able to do 10 gig end of 2002. To the rest of Europe, and global connectivity will be at multiple gigabit Ethernet. Right, this is the project, the Gigaport network project in perspective. The orange part is the national research infrastructure. Today SURFnet4, real soon now SURFnet5. The connected organizations are the white clouds to the upper left part, and then there are the other white clouds are the access projects, and to the left the blue boxes are the external connectivity. Well, I mentioned SURFnet4, SURFnet5. This picture shows how we do the improvements of our network, and how we build the next generation of our networks. There always is a working network while we start building the next one. There are countries in Europe that do differently. They build a new network, have very little time on testing it out, but have to switch over real soon now. And that means that when you would use a technology like this to make this visible, the parts would be next to each other, and we always build on top of. That means today we have SURFnet4. This network will be available until the very end of next year, and SURFnet5 is being built today, and there will be half a year, the first half year of 2001, where the major institutions that are the universities will be connected to both networks. Another picture of the Netherlands, and this is our topology we have today. The backbone is the green lines. I'm a little colorblind, so I think it's green. The green lines are the backbone. Speeds up to OC12 in there, and the rest of the POPs are connected at OC3. All the external connectivity is out of Amsterdam. Right, let me take you now to the specifications of SURFnet5. As I said, it will have to be at least 100 times faster than SURFnet4. There should be no SDH, ATM or whatever in there. We plan on having access to the network at 20 gigs per second, at least give the universities the possibility to connect at, for instance, 2 times GigE or 2 times STM64, which is the US equivalent to OC192. And the core of the network will be 80 gigabits per second. And as I said, we're introducing new IP features all the time as soon as they become available. Multicast I mentioned, IPv6 I mentioned, and we're heavily looking into MPLS things like VPN. For instance, we have convocational high schools that have many offices in the Netherlands, and the main office wants to connect to the remote offices through VPN technology. And together with them, we are developing this service. Traffic engineering is on our agenda, and one of the first talks of this NANOG meeting was on Sunday. It was about restoration. We are looking into fast reroute for SURFnet5, and I'll come back to that later. And all this is done in partnership with the industry. We had a tender out last summer. No, that was too recent. The summer of 1999. And we had 7 proposals to our tender for building SURFnet5 with us. And out of those 7, we selected Telfort and Cisco Systems to build the next network with us. If I zoom into the timing for the whole SURFnet5 build-out, we started early this year with building the proof of concept network, which we call the pilot network, and it will be available until the December 1st timeframe. We are today building the pre-production network, which will be a network that will be available to users, but SURFnet4, our current generation network, will be still available to them as well. In the summer of 2001, we will start tearing down SURFnet4 network. This process should be over end of next year, and then SURFnet5 is the only thing that is available. And SURFnet5 then will be available until the end of 2005. But in the meantime, we expect that there will be a Gigaport 2 project, and we will have the ability to work on SURFnet6, whatever that may be. Right, the pilot network is there, as I said. It's a 4-node GSR Plus network running on dark fiber, 2.5 gig POS framing in there, and as I said, it's up and running. We are doing performance testing on this network right now. We have a gigacluster, which is, well, a high-end switch and a high-end Ethernet switch with a lot of Sun and Dell computers attached to it for generating and syncing data up to 3 or 4 gigabits per second. I'll show you some results on what we found. We are doing, and as I speak right now, my colleagues back home are doing the traffic engineering fast reroute testing, because that's the technology we will be relying on for resilience, for redundancy in SURFnet5. Together with Cisco, we are working on, for instance, things like SSM and IPv6. Right, this is a picture of the SURFnet5 network, and as I said, 4 nodes. Amsterdam has the connectivity to SURFnet4, so it's connected to the rest of the world, and the network does POS framing. This is how the gigacluster is connected to the network. On 2 locations, we have connected a Cabletron, or I should say Anterosys, SSR to the network on first 1 gig ether, and today it's connected on 3 gig ether, 2 times gig ether between the router and the switch. And attached to the switch are per switch 3 Sun workstations and 5 high-end Dell systems. The combination of the Dell systems and Sun systems is able to generate up to 4 gigabits per second of traffic. And this is some of the results we found. The blue line, which is the lower line, gives the results, the throughput results between a few Dell systems in Enschede, which is to the lower part of the picture. Let me go back. Enschede, sorry, the upper part of the picture towards Eindhoven, the lower part of the picture, using the direct connection between those 2 routers. The blue line shows you a throughput of 300 megabits per second, just using 1 system. That means there's enough room in the network for having more traffic, and you probably run into what the systems can do, what the systems are capable of handling. The interesting thing we found is that if you use 2 hosts, which is the green line, that you can fill up the network until 900 megabits per second. So there is more to it than just the limitation of the systems. Using 3 hosts will still give you, well above 900, say 930, 940 megabits per second. This is an interesting phenomenon. We have been trying to explain why. Up till now, we've not come further than, window size starvation, or, turning the TCP protocol into a stop-and-go protocol. The round-trip time is, as I said, the Netherlands is small. The round-trip time between the 2 nodes is roughly 3 milliseconds. Okay, this is there, the pilot network is there, and we are now building out the real network. The topology of the network will be using a collapsed backbone in Amsterdam with 2 locations far enough apart for a plane to land in between. So any disaster happening to part of the city will not take out the entire core. Each site, each backbone site will have 2 GSR pluses interconnected at first at 10 gig POS, and the 15 POPs will be connected to each of the 2 core locations at 10 gig POS as well. So it's rather boring. It's 10 gig POS all the way. The status is it's currently being built, and we expect that 14 out of the 15 locations will be available before the end of this year. And the universities will connect to both networks from then. That means that they will put all their payloads, all their traffic on SURFnet5 until there is a problem and they switch back to SURFnet4 using a fast restoration protocol. This is a picture of the final topology. The 2 white boxes in the middle are the 2 locations. It's Hampoint and it's Sarah, for those of you familiar with the locations in Amsterdam. Each location has 2 GSR pluses interconnected, and then the POP locations, concentrators mentioned on this picture, are connected to each of the 2 locations. And the white lines towards the POP are lambdas, 10 gig lambdas, coming from the carrier. And there's no protection inside the lambdas. So we will do restoration, we will do protection on IP level using fast reroute. The idea we have for this is that this is a picture with just 2 POPs in there, POPs X and Y, and we will have an LSP that is the primary LSP that will carry all the traffic between those 2 POPs, and there will be a backup LSP, and with fast reroute we expect that we can switch over from LSP A to LSP B as soon as there is a problem. We are testing, well, the proof of concept testing is being done today on the pilot network. This is the picture of the Netherlands again with the 15 locations, the 15 concentrated locations for SURFnet5. And as you can see, we will be going to the rural part of the Netherlands as well, and we will be adding 10 more POPs, at least that's the plan. Right, the production network, which will be available from the summer of 2001 on, will be just the pre-production network, but then put into production. We will have a service level agreement with the vendors. And we will then start, and we'll have half a year to do it, to complete it, the migration of all the customers towards the new network. Part of the contract with Telfort and Cisco Systems is that the core of the network will be upgraded. The 4 GSR pluses in there will be upgraded to the next generation network, next generation platform, whatever that will be. It's in the contract. And as I said, the network will then be available as the main platform for the research and education customers in the Netherlands until the end of 2005. Right, I said I'll show you the connectivity to the rest of the world. Today, SURFnet4 and later on SURFnet5 will be connected to the global internet on OC12, and this is implemented as 4 OC3s. 2 of them are transatlantic OC3s running into our own POP in New York City. It's a contract with Teleglobe, and we do have routing equipment in 60 Hudson in the Teleglobe POP. And the other 2 OC3s are contracted with level 3, and this is not transatlantic. This is just connectivity inside the city of Amsterdam, where level 3 is present, and we get global routing from them in Amsterdam. Right, going back to the Teleglobe solution, the Teleglobe part of the solution we have, right from our routers in New York City, we have an OC3 into Abilene, into the New York City Abilene POP, and we have an OC3 to the startup in Chicago, where we peer with many North American and Far East research networks. Through there we do have direct connectivity to VBNS, CANet3, and Singaran, and all the networks we have peerings with. For Europe, we connect to Dante's 10155 network, which is a network that is being upgraded today to 622 meg, and we will be using gig ether to connect to this network. And gig ethers are up since yesterday. Amsterdam Internet Exchange, we connect on gig ether, and it will go to 2 times gig ether in December of this year. This means that we have a lot of external connectivity, and we always try, that's one of the philosophies we have, we always try to be before the demand is there. I can say that all this connectivity I now show you is congestion free. So no, we do not do red on our links. This is a picture I stole from one of the presentations that was given here in the US by the high energy physics, and what this picture shows is how Europe is seen from the high energy physics world in the US. And well, the first slide I showed you was where the Netherlands is. I do not have a pointer or such, but where you can see a very small green dot, that's the Netherlands. That means there's no packet loss towards the Netherlands. The round trip time is very small, and the percentage of unreachability is 0. And there are some countries in Europe that have different pictures. So, well, I dare to say that we're pretty proud of this. This will not be the end. I mean, if you look into what we plan for 2002 regarding external connectivity, we plan on having OC48 global internet connectivity. We will be issuing a tender real soon now for this, and the ingredients of the tender will be OC48 global internet connectivity out of Amsterdam, an OC12 solution towards Chicago, since we want to stay connected to the startup, and this can be implemented with an LSP or an IPVPN or what have you. And we are also looking for a transatlantic lambda for doing research into optical switching. And when Bill Centeno was up here yesterday talking about optical BGP, he briefly mentioned this. And we will be doing this together with Canary and the startup. And the iCache Center in Chicago will also be part of this initiative. This is the end of what I wanted to share with you. I think there is 1 minute or so for questions. Any questions? Guess not.